Welcome to Wise Guys Unprompted. I'm Zachary Kreider, joined by my co-host, Martin Holstay. Here we cut through the noise and get real about AI and cybersecurity. No fluff, just insights that matter. Each episode, we break down the latest developments, decode complex topics, and share unfiltered perspectives on how AI is reshaping security. Whether you're a CISO, security professional, or just curious about where technology is headed, we've got you covered. So let's dive in.
Okay, welcome to our first ever edition of Wise Guys, where myself, Martin Holstey, I'm a CTO for AI at Trellix, and with me is my co-host, Zachary Kreider. Zach, do you want to introduce yourself?
Yeah, and so Zachary Kreider, so Director of Strategy and AI here at Trellix as well. So I'm in the services organization, and both Martin and I have been helping drive innovation and adoption of AI across the company now for the past 2 years. And we've made a lot of gains, especially working with the different models, open source models, on-prem and cloud hosted.
Yeah, man, it's incredible to think about 2 years ago what what it looked like in AI 2 years ago. It seems like 20 years ago. The stuff that we can do now. I mean, I remember when we were first messing around with the very first edition of Llama, and you put a prompt in it, it would just put out a string of A's. It was just complete junk. It was so hard to get anything working. But we recognized right away that this was something new that our industry had never had before, and that's really what started us on this journey. And so we're decided to, we had things on a weekly basis we wanted to talk about, and we've enjoyed so much talking with customers. We're gonna have some guests on here, but just getting the word out on all the different things that we're seeing and having this conversation live is something that we've heard from a lot of people they'd like to see. So we are obliged to at least get this stuff out there. So we'll go through a few things today along the lines of all the different models that are out there. That's going to be a topic for today. But yeah, look for other episodes that we have coming up with different use cases. We're going to have different people on, and there's just so much to talk about, and this stuff changes so frequently. We want to make sure we have regular updates so that everybody kind of has a good feel for what's going on out there right now.
Okay. And you brought up a good point. So like when we started this 2 years ago, it was ChatGPT kind of like lit the fire into this, right? And then it was every model, I think, that was on Hugging Face, right? So I know originally we started with Falcon, and then all the different open source models out there. And to your point, results varied quite differently depending on which model we launched out there, and then fighting over resources of being able to launch the biggest model. And we found out the biggest isn't always the best, right? And so I think some of the research that we'll talk about today that you've done is pretty eye-opening of kind of the models that are out there and the quality of the responses that come back, specifically for us, right? Because we're focused on security of, can it actually help out an analyst? How much does it hallucinate? What's the value of the results that come back? And, the results that we'll get here into a minute, it's pretty eye-opening of the data that we've seen.
Yeah, absolutely. And you think about, this all really started with, I would say, GPT-3 about 2 years ago. I think GPT, the 2.5 was the first thing it could actually, transform input into output. But GPT-3 was the first time we ever saw it, be able to create something on its own with a minimal prompt. But even that wasn't really usable. So it wasn't until, we got into the ChatGPT era, and then you got Llama getting improved over the last 2 years that really saw something. But we've been doing, honestly, the security analysis stuff like this for about a full 2 years now. It was, almost, because it was March of 23, I think, is when I first got the analysis module up and running. And it was, it was pretty minimal, but it was the first time that we'd ever actually made security decisions using an LLM. And now when we go through today, it's incredible to see how far we've gone. So to that end, we've been doing some research here lately. And we call it research, but honestly, one of the main things that you have to keep up with all these new models out is, am I using the right model? And I think that's been a huge question, being able to reliably test to make sure you're using the right model. And then at the same time, you're doing your prompt testing, right? So your prompt engineering, prompt versioning, and a lot of that. And we're just scraping the surface of what you can do there. But making sure that you're getting the right output when you change the input, right? Classic CI/CD pipeline kinds of stuff. So with that, this was a blog post I did jointly with AWS, a great partner of ours, a few weeks ago. And this was sort of the first unveiling of some of the stats that we'd seen. So you can see the link there and read more about it. But I think this was one of the first times that we really had a full qualitative and quantitative comparison between what was going on. And so just to kind of break this down, we're looking at it on, two different ways, on two different axes here on the scatter plot. And the first one is, did this thing make a decision that we agree with, yes or no? And obviously that's a huge part of this. And so that's, something we, worth a full axis, right? And then the second part was, how well did it explain itself? And there's a really interesting dynamic there, where you can get the right decision, but if you don't know why that decision was made, then it's not very helpful for an analyst because you can't really trust it. And that's been sort of an underlying theme, I think, that we've seen since the beginning. If you go all the way back, 10, 15 years through machine learning and how that all came to be in the security industry, you get, an anomalous reading and say, oh, this is, this much anomalous. Well, why did you think it was anomalous? What was the thing that made it stand out? What made it weird? And it's so funny to me to look back at the last decade of working with a lot of really brilliant people on machine learning. And now you can dump a very large amount of data into, whether it's ChatGPT or Bedrock or any of these LLMs, and say, what do you think's weird in here? And it'll just go through that and say, yeah, these 3 things were super weird. Here's why. And then it'll outline it. So on this chart, the detail there is that write-up and how good that write-up is. And to make this, we had to come up with a framework for evaluating it, which, of course, spoiler alert, was Gen AI to read that in. But it's all about the framework that you give it as the operator to say, here is the instructions, or here is the framework that I want you to use when you're evaluating. So I kind of think of it like anytime you're scoring an art, right? So whenever there's like a musical event, I remember way back in the day in high school, I was in different musical groups, and we would do these competitions, and you get ratings from judges. So you could, same thing with like platform diving, right? Judges give a rating. And so there is a way to go from something that is, generally subjective to objective. And that's been a really big part of this. So you can see that on the y-axis here is the rating for the detail. And that's based on that kind of analysis. So there's quite a pattern in there.
Yeah, now, when you did this, like, did you run any challenges with scoring? Because I know, right, originally when you started this, right, scoring specifically for Claude, right, it liked to give itself an A+ every time. So, like, what challenges did you run into with the scoring of, being critical and how it scored other models and also itself?
Well, it's funny because so you see the similarities with the scoring and the decisions that it makes. Now this one, I basically validated that I agreed with it, and the sample size wasn't so high that I couldn't at least visually make sure that this was spitting out the right stuff. But you raise a really good point, and I've seen this. So we have Google Workspace, and I've seen this with Gemini, where if you ask it to review something that you've written, and some of it you wrote and some of it wrote, it will always say the stuff that it wrote was better. And even if you don't like it, and I had this happen to me yesterday, I was making a bunch of tweaks on something. I'm like, oh, this was too dry. I want to change this out. I say, oh no, you should have added an analogy here, or whatever. And it'll be exactly its writing style. So yes, there's definitely something to be said for AI judging itself. I guess that would be true of humans as well. They expect to see things, the way that they would do it, and that makes total sense. So that's a great point. On this one, the correct decision that we're referring to on the chart was whether or not it decided to escalate a particular security event or alert. And that's something that we could at least, as a human, look at and basically verify that, yeah, this is our gold standard for how we assume this should happen. But you raise a good point, because when the data set gets bigger, that you can't have people manually checking on that. You have to basically, this goes back to that, trust and transparency with the model. Trust that it is making that right decision, even when it comes to judging another LLM. So you get this really cyclic kind of thing going, or this chicken and egg, where it's, okay, how do you, make sure that everything is consistent? But there are ways that you can do that, and it did take a fair amount of doing to hammer out, the exact framework to use for that judgment. So you could see more about it on the blog post there. So that led to some recent work, and I just presented this yesterday at a conference called IntelliCon. And this was looking at basically the level of analysis. So you saw the sort of y-axis on the last chart. This does a little bit more of a deep dive, and this framework's a little bit different. It's looking at this in a more specific way to figure out, was this better than a human? And then the scoring is, Was this at the senior analyst level for a security senior analyst or a junior analyst, or was this below human level? And then critically, the bright red there is mistaken. And I think that was a really big part of this, was understanding, okay, you might have made a really good analysis, 2, 3, 4 times, but every 5th time you made a big mistake. Is that really usable? And that's the big question, right? Is, okay, we all know that LLMs can make mistakes, it can make hallucinations, but understanding how often that happens and under what circumstances and what to do about it, that's what really allows you to go into production with something. And to
when you did this, like one thing I know that always comes up when we talk to customers, even internally, right? Token count, right? Of like how many tokens it used, but then the big one is cost, right? Cost always comes up in every conversation that we have, more often than I think you and I like when we have this talking about Gen AI. So just curious, like when you ran through this from a model standpoint, like did token limits hit you at all from input output? And then kind of what's the cost that you've seen just from taking normal security events coming through?
Yeah, I didn't hit any limits specifically for doing this testing, and I was doing a bunch in parallel, which really is again, I mentioned we're partners with the AWS, and that's something that's great about using Bedrock on something like this is, it'll actually do routing behind the scenes and make sure that if one region's getting overloaded, it'll route your prompts to a different region, all within the same country, so you don't have any GDPR concerns or anything like that. But the ability to do that is a big part of this. But the cost is huge, and I've seen go to that slide. There's a really big difference in costs themselves, and this is, I have a leaderboard here which has that called out, and this one, let's see here, there you go. Check that out. So this is taking out the the stacked part of it, whether it's better or not than an analyst. This is just the raw numeric score, and so you can see them ordered, best to worst essentially by score. But look at the difference there. Nova Micro is 100 times cheaper than Sonnet 3.5. And Sonnet 3.5 performs the best on its analysis, makes the right decision the most. But Nova Micro was at let's see if I'm reading this right, about 27, and the top score from Sonnet was 39. So you're at 65, 70% effectiveness rate there comparatively for 100 times price difference. And that's really been a huge part of this, is understanding when we use the right model. And we've got some blog posts coming out here in a little bit that'll dive into that significantly. But having the ability to choose which model you're using is a big part of this. And then knowing not only the price point, but what are they going to be good at? Because 100 times cheaper, oh, okay, we'll just use micro for everything. Well, your write-ups definitely matter in some of these really critical situations, right? If you're making a security decision, and you're probably going to want the best possible security decision for that. On the other hand, you can stack them together, and so you can kind of, what I do call it, model tiering, where you'd have smaller decisions made by smaller models, and then they can kind of funnel that up, and then have fewer but more important decisions made. So it's kind of your classic AI org chart, if you will. Micro is really interesting because it's super fast. And it's super cheap. So it really opens the door to doing all kinds of things that were completely cost prohibitive before, not just in security, of course, really in anything. I was talking about this with a number of folks at the conference yesterday, and they were pretty blown away. And we started going through some things you could do, like looking at things on a per log entry basis. Like if you're reading in something like a CloudWatch log from Amazon or a syslog locally, something like that, and saying, hey, does this log that I just got make sense for when you compare it to the last 100 that I just got, and do it for every single new entry? That's something that would be incredibly cost prohibitive if you try to do that with the expensive models. But being able to do that when it's just tiny fractions of a penny per call, then you could actually start to look at that in all these other areas that were just completely impossible before.
Yeah, and also too, like I would say, you got two of the newer kids on the block, or at least for this week on this chart, right? With Nova from AWS, because they just launched that around November. And obviously the one that everyone's been talking about now for like the past 3 weeks, DeepSeek. So just curious, like I know DeepSeek's got a lot of attention from just a lot of people for different reasons, but just what did you see from like the quality standpoint of being able to reason with security events versus like code or just mathematical responses?
Yeah, DeepSeek, and this comes out in the actual write-up. So let's kind of walk through that, because when you see the actual output, it makes a lot more sense for what the differences are. So I'll go through them really quickly here. And this is basically the gold standard. So this was Claude being able to decode inline base 64 encoded PowerShell commands. And this is my gold standard, because this is something that a human can't do. So when I say better than a human, it's doing things like that, which is just inherently not only decoding things, but then understanding and processing the information that's been decoded. And I want to be clear, this isn't an agentic thing where it's saying, oh, I need to decode something, I'm going to reach out to an agent and have it decode it and bring it back. This is inherently in that same chain of thought, being able to decode it. And that's a big difference, because if you have to call an agent to go out and do the decoding, that breaks that chain of thought. Just like a human, you get distracted. So
you bring a good point, because this was like our aha moment, like 7 months ago, I think, because you were doing some testing, and I just remember you pinging me saying, hey, like, I didn't tell it to decode this, and it just decoded this PowerShell file on its own, and it got it accurate. So to your point, like, there's no agentic behind the scenes of, hey, find base 64, go decode it. Like, Claude just knew to do that, and a lot of the models are starting to pick up on that that you found, which is, to your point, like, for a human to do that, someone have to see that. They're going to escalate it to a tier 3 analyst. They're probably going to copy it out, go paste it in a browser or something like that, which is all time, right? Where Claude's doing this within the matter of a few seconds, which is really amazing.
Yeah. And this is the one that really started it for me. So Tenable is a great partner of ours, and we have a lot of customers that have Nessus agents. So this ability to look at this from our demo environment, to be able to not only decode that Nessus command, but this is the critical thing, it matches it up and realizes that inside of the encoding was an OS version, an IP address, and the rest of the Nessus plugin info. So right there, I was able to validate that this was the correct Nessus command. This wasn't, a bad guy using this to exfiltrate data. And that's what happens 99% of the time. But if no one's actually checking that, then you can't figure that out. And the critical part was that Claude had read the whole internet. So it had read all the Nessus documentation. So it knew that that was, in that chain of thought, the right stuff to see there. And that's the biggest difference, because if you go and grab it and then drop it into the middle of the conversation, it won't be able to apply that kind of knowledge. But you're right, that was such a watershed moment to realize that I didn't tell it to decode base 64. I said fully understand the commands that are being read. And it could do all of that. So that means it's not decoding just base 64. It does that for hex values, does it for all kinds of stuff, because it's been told to understand what's going on. And that was the moment where I realized that we were in a new world.
I think you had a web certificate, right, at one point, where it actually decoded a web certificate without asking to, or something along those lines.
Yeah. So now this can go sideways. So here's an example from Mixtral. And Mixtral said, oh yeah, I decoded this PowerShell script, and then it puts a PowerShell script there. Now, here's why testing these models is so important. It completely hallucinated everything. And you can tell right away, because what's the very first thing it says it decoded? It says Perl. And sadly, I know Perl really well from back in the day, and that's not Perl. That's definitely PowerShell. So you can see that it was told to do something, and so it just imagined what that would look like. Here's what the actual decoded value was. It's completely different. And that's really scary as an analyst, because if you think, well, how can I trust that the system is actually doing what it says it's doing? And the short answer is, without doing that diligence and figuring out whether these models are reliable, you can't. So this is a huge part of it, is understanding, how, just because it says that it did something, did it actually do that, and having a framework in place for knowing that. And this was part of the analysis that we're doing in our framework. You can see the scoring. And this is what's so funny is Claude, which does, as we showed you, decode it properly, noticed it decoded it incorrectly. That's how I knew about this. It said, oh, by the way, this one was totally wrong, so we're giving you a 0 on your ability to decode here, which is a little generous on some of the other parts, because actually, if you look at the analysis, the write-up was actually pretty good. So it said this is AirWatch, which is a mobility management solution. Yep, that's all true. And it's running PowerShell. That's all true. And then it just fails on the actual decode. So the analysis in our write-up, I figured out, okay, well, this part of the analysis was good. This was good. But then, oops, giant mistake, scores 0 there. And then that leads into the rest of the evals here. So when we look at, back to the chart, the difference between better than a human or not, the other part you have to take into consideration is those errors. So that's where that red is when it made a big mistake. And so that's why you have to weigh this. So even though Gemini here did a really good job going through all of the different analyses, and you can see that here, here's Gemini Pro 1.5 Pro. It did the best job of all decoding the base 64, and then it made a fatal error. It said that, well, I decoded this, but this isn't standard for MDM software. This was very much standard for MDM software, but it wasn't able to put those things together. So the fact that it could decode the base 64 ended up not being valuable because it then made the wrong decision and said, oh, this is a bad guy doing something, when in fact, MDM software often disables the automatic Windows updates because that's what MDM does, is handles the Windows updates. And so it fundamentally didn't put together that MDM software would do that. Meanwhile, Claude did. So those are the kind of nuances that you see. And then meanwhile, you mentioned DeepSeek. So here's the 7 billion tiny version. This can run on a laptop. And it said, okay, yeah, I noticed that there were some system services and health monitoring updates. Okay, that's, not wrong, but it's not super involved. Nova Pro did a pretty good job, and it did about as good a job as any of the models without doing the base 64 decoding. So it didn't go sort of the superhuman route, but it did make the right decision. And that's a really interesting contrast between Claude, Gemini, and Nova, where Nova was kind of the medium, where it knew that it didn't decode it, and so, but it also knew what MDM did, and so it made the right decision with a little less of the write-up. Whereas Gemini was, doing a great job on the decoding and then failed on the response, and then Sonnet nailed the whole thing. So being able to see those kind of nuances is really tricky, and that's why you need that kind of overall framework. So that goes into the overall scoring, and so you see back to this one. We have that leaderboard lined up. It takes all of that into consideration. And then as a little added bonus here, the green ones are the ones that you can run on a laptop on CPU. And basically that means that you really can't get better than a human performance on anything currently that can run on a laptop. That's kind of the upshot right now.
So that's a good point you brought up, because predominantly everything we've done has been cloud-based or cloud hosted. I would say probably in the last 4 months, we really started looking at like on-prem, just because there's a lot of those customers, right, or environments that, they can't connect to cloud, whether it's OT environments or heavily regulated. So they have to rely on something that can run like on-prem on a container or laptop. So I think it's pretty interesting, right? I think the models will get there, but like where they are today, like, they're a little bit farther behind than what's in the cloud from the quality that comes out. But to your point, this was just a straight shot at the models. If you did maybe some more agentic or more programming on the back end to handle it, you might get better responses, but this is just a straight shot at the models and the quality that they return just running on CPU.
Yeah. And your teams have been working on, some more of the code generation. This is on sort of the reading comprehension analysis capability. You want to talk about your experience in testing different models for code generation?
Yeah, it's very similar to like what you saw, right, with the security responses. To your point too, like originally when we started looking at all this, like the open source, like the Falcons and the Wizard models, that were open source. To your point, you would ask it write a Python script. It would maybe write 2 or 3 lines of code, and then it would just forget and do AAA, or just put in like a bunch of placeholders of, hey, you should add functions in there. And as we kind of progressed and started working with AWS on their Bedrock solution with Anthropic, their Sonnet models, like they're doing as good of a job as their developers, right? They're able to follow instructions, fully write out full code, not hallucinate or get distracted. And it'll actually go back and correct itself where it put a placeholder to write a function. It'll actually go back in the code and actually write that function. And we've even seen the same kind of quality too from like the Nova models too. I mean, they're brand new. It's 1.0 for AWS, so they're only going to get better. But just from writing like standard Python code or just scripts that you'd have to use from a security standpoint, Nova's getting right up there in the same kind of quality. And then Gemini's right there behind it. So those are probably the top 3 that we've been really working with from doing a coding standpoint of writing either security content or actually product code itself that we're able to ship.
Yeah, that's awesome. It's been so interesting to see that, iteration between the models and what you can do. And would you say that, I mean, in my experience, and you guys have been doing more coding than I have, but it seems like sort of there was a threshold that was met by a lot of different models here just in the last maybe 3 months or so. And prior to that, your code really varied between them. Do you see a little bit more of a commercial or a commoditization, you'd say, on what's able to produce code?
Yeah, I would say like going back to like kind of what we talked about before, like some of the models are really, really good at writing Python. But if you get outside that wheelhouse and say, hey, write me a program in C or Go, like your results may vary, but it's gotten much better in the quality, like the training of the models from the different vendors, even the open source ones. They've gotten much better in the quality of the output. But Python is probably the most predominant one. I think all the models really excel at. Because that's the most common language I think that most of the developers are focusing on that are building the models. So they want to make sure Python's the best of the output. But also too, that kind of goes in something too, I think you just stumbled upon like a couple months ago, is some of the models are really good at coding. Some are better at like reasoning. Some are better at just writing responses. Do you want to go into that a little bit? Because I think DeepSeek was probably the first one where that we kind of realized that, where it's really good at more mathematical than actually writing responses and
let me bring that up. So the DeepSeek, let me go to the model evals here. Right, like that. So this was on a per model basis, and you can see actually DeepSeek 70 did pretty well. And I think one of the more interesting parts about it was that it never really went too far out, but it did a pretty good job doing the write-ups. The main thing, though, to your point, is that it seemed to do a lot better job if it was anything more recall based, as in something it had been trained on. And I think that's kind of the biggest thing to watch out for and to make sure that you're testing for is the difference between, can you do something that probably showed up on some of those like math benchmarks or anything like that, that's more rote memorization kind of stuff, versus can you take that knowledge, and back to my comments around chain of thought, can you extrapolate on that? As in, can you or infer because of X, Y, and Z that this next thing is going to happen, right? Do you fully understand? And I've also seen that on the model quality differences when you're talking about quantization. So things that have been quantized are less likely to be able to make that kind of leap. And that's kind of what you give up for a model to, reduce in size, and therefore the cost. Is that you might get really good, performance for something like translate YAML into JSON, or, some templating kinds of things, or, basic questions and response. But when you ask it to do that more reasoning or get into some of the more heavy duty stuff, as in apply knowledge that's in your parameters, then it gets a little trickier. And I think a big question that's going to start showing up there is when we look at model distillation, where you're saying, okay, we're going to take some expertise from a knowledge base that's in parameters in a large model and distill that knowledge down into a smaller model, but just that specific knowledge. So maybe it's, biology, maybe it's security, whatever that is, right? Some technical knowledge, and you're going to put that in there. But because it doesn't have all of that other knowledge to draw from, it's kind of like it didn't go to college, right? It doesn't have that broad understanding of how the world works and thinking in systems and stuff like that you get when you have all those parameters at play. So I think that's going to come out here in the next few months as people are trying to find the right fit, because there's a lot to be said with doing that. But I think this also goes back to how far can you get with fine tuning? I think that's another really big part of this. Because if you say, well, here's how I want it always to look, what you're doing is that might work in some kind of low stakes situations, like the classic customer support bot, right? You're saying, if you see this, do this, if you see this. And so it's just kind of one level above that, scripted situation, right? You give it that really strong flow chart to kind of go through and say, if this, then that. But when you're trying to have it really be able to make a good decision, then it's got to have a lot more at play. So it needs to have a lot more information. And that's really hard to sort of artificially bake in there if you're going to expect it to, really jump to conclusions or figure things out like a human would.
And you bring a good point. Like, so as we've gone through all this, like fine tuning, I know it was kind of the big thing that people wanted to dive into, or even RAG. But I would say a lot of stuff we've done, it hasn't been with fine tuning or RAG. This is just straight to your point, like knowledge that the models have or ability to reason. And this is like the results you've gone through, right? This is just the models out of the box, their quality of response and their capability to reason on that results. Like, we haven't fine-tuned these models or gave them like security examples to improve their knowledge. This is all how they've actually been trained, which is very eye-opening, because it helps us go to market faster, right? And a lot of stuff that we've been working with, we don't have to train it of the whole security landscape of what are good events, what are bad events, to be able to look into to make a decision. Like it's being able to reason and determine that on its own, which is big, because I think a lot of people, they get stuck on, hey, we have to fine tune or do all this custom training to make our models better.
Yeah. Well, it's kind of, I always go back to the example of, if you say it's always bad when Bob logs in on a Tuesday, then what have you really taught it, right? It's, well, Bob logged in on Tuesday. I'm like, that's like a security rule, not a LLM situation. That's a rule or intel or however you want to think of it. That's a binary situation. Either Bob logged in on Tuesday or he didn't. And that's kind of what the problem with fine tuning is unless you have that really specific use case, which again, like a customer support chatbot is, right? So there's plenty of times when fine tuning makes sense, but it's so easy to forget that once you get out of that very specific, data set, you're going to run into problems because it's going to basically make the wrong decision very frequently. And the other part is that the more fine tuning you do, the more it hallucinates, because the more you say, hey, what happens now? It'll just look back at, whatever it was given for fine tuning and default to that. And I've seen that come up even when I was making these benchmarks with different prompts that I was trying out for doing that framework. And occasionally I'd get, and you see the Llama 11 billion here, the reason it's got so many mistaken ones listed is it had invalid output a lot of the time. And I noticed a few times that during the analysis from some of the earlier prompts that I was using for the analysis, that it would basically hallucinate in like a good write-up, even when there was no write-up, because that number one time to get a hallucination, right? When it's the model's like, ooh, I was told to produce something and I can't produce something. So here you go. Here's I'm going to turn my assignment in late, right? Or however you want to think of it. So you have to make sure that it basically has permission to admit when it's wrong within that prompting framework, or it'll start doing that. But the more that you fine tune, especially on those smaller models, they'll hallucinate a ton. They'll be just much more drawn to that fine tuning data set. Then, it's not like you're adding to it, you're really layering it on top. And it kind of has to look through the fine tuning data set to get to anything that might've been under there. And, for any of us that are bad at searching for things in a cluttery drawer, where it's always under something, right?
Right.
I would always say that the key is to look under, she would say. And that is, it's harder to do that. And so the LLM is going to grab the first thing it sees, essentially, and that's whatever you fine tuned it with. So I think that's an underappreciated piece of fine tuning, is that it just introduces so much bias that you're going to get that answer that you fine tuned it with the majority of the time. And again, there's a lot of situations where that's exactly what you want. Right. So it's not that fine tuning is bad, but you got to understand exactly how that works. And then critically, like the thing that I use to make this, like you have to have your own sort of QA process for measuring whether or not any of the things you're changing out haven't, created any situations that you're not looking for. And I do want to comment on some of the other approaches I've seen to doing that. And I wouldn't say they're wrong, but a lot will do more like a golden standard kind of thing. And they'll say, consult this known right answer, and then make sure that the LLM output matches that. And that's not a bad way to do it. I think that the problem with it is it doesn't, it's like a unit test versus an integration test. You're only going to be able to verify that small piece of what the LLM is going to do, and you don't really know what it does with new information.
Right.
It's kind of hard to measure a broader set of input with that, but it's fine. I wouldn't say don't do it, but it's got, I would say, limited coverage if you're going to do the sort of golden data set. But it is good for at least like a unit test, sanity testing, and making sure that, you're not getting completely invalid output or whatever. It hasn't completely changed its mind on something. And I mean, we've been doing this a while, and I'm still just floored every time you change one word in a prompt and you get a completely different answer. It's really interesting.
Yeah, well, you have to change your chart probably the next week with the 5 new models that'll probably come out by then. So.
Exactly. Well, and that's what's so fun about it, is you just drop the IDs in, we do testing on Bedrock or, other APIs, and, it'll just add it to the fun. So once you get that framework up and running, then you're in a good spot for, easily validating what's coming out and seeing if it could help you. And most of the new models you're seeing are generally lower priced. We're seeing that quite a bit, or they move the price kind of for everything lower. So that's also really nice to know, does that mean that a lower price model, maybe I should start using that one now, because before it was about the same, but it was the same price before, and now that one's cheaper, right? So it's being able to economically take advantage of whatever is best out there for you, the right fit.
Cool. No, this has been like, when you showed me all this was really fascinating and eye-opening, right? Of just the quality and the scoring of the data, which I think this is what a lot of people have questions about, especially on the Gen AI front of, which model should we use? Like, do we trust the actual output? That comes up a lot. And so I think that's very critical, right? Of the data being able to provide on that.
Yeah. Well, I think it's the limiting factor on what are the possible use cases for Gen AI right now. It's, well, how much do you trust it, right? And you get into the full self-driving car kind of situation where it's like, well, you got Waymos out there and we're trusting them, right? But then, in TSBs, like, now you're going to have to be in the seat, because we've also seen them make the wrong move sometimes. So similar on pretty much any LLM kind of like that. You got to know just how right is it, and in what situation is it being trusted, and what are the fail safes, right?
Right. Cool. Yeah. So obviously this is our first episode, right? We're gonna have a lot more coming out. So I would say if you have ideas or like other topics you want us to cover, like, feel free to drop it in comments or reach out to us or reach out to your Trellix rep. We're happy to jump on calls with you or talk through AI use cases that you might have. But definitely look out for more episodes coming soon.
Yeah. Thanks for joining.